To understand the groundwater shortage our community is facing, we must go deep underground. Here, at several hundred feet below the Earth's surface, the groundwater that people in the Soquel Creek Water District use is stored between rocks and sand. Rainfall seeps into the groundwater aquifers and slowly flows underground to the ocean, or returns to the surface as a spring or directly into a river before reaching the ocean. The freshwater underground creates a buffer near the shore where freshwater and salty ocean water meet. When wells draw more water out of the ground than is naturally replenished by rain, groundwater levels begin to drop. Salty ocean water moves inland and mixes with the fresh groundwater. As seawater moves inland, wells that once drew fresh drinking water become salty and unusable.
There are two factors that cause saltwater intrusion. The first one is the natural or geological factor, which comprises of sea level rise, unbalanced precipitation, evapotranspiration, and climate change and weather events. Another one is the anthropogenic factor, which is due to human activities and also intensification of hydraulic construction. Rapid global urbanization, population growth, and all series of anthropogenic activities have resulted in the rise of sea level. In the event of sea level rise, the saltwater is being pushed to landward in a higher pressure, which increases the possibility of the groundwater to be contaminated. Apart from sea level rise, the unbalanced precipitation-evapotranspiration ratio is also contributing to saltwater intrusion. When the precipitation reduces, the rate of evaporation increases, hence leads to slowing down of freshwater, which makes the aquifer more vulnerable to saltwater intrusion. The saltwater inland movement can also be worsened by the climate change and weather events. Weather events such as storm surge, hurricanes, and floods can greatly increase the intrusion of saltwater owing to the extreme high pressure. The saline floods will penetrate into soils and cause saline contamination within a short time. There is a case study that occurs under the natural factors such as in Texel Island. Texel Island in Netherlands is bounded by North Sea on the west and Wadden Sea on the east. The main landscape consists of mostly low-lying lands reclaimed from the sea on the east, protected by sand dunes on the western side of island and dikes. The average elevation of the island is only 2 meters above the mean sea level, while some low-lying land areas in the east are even below mean sea level. An isolated island from the mainland, the source of fresh water is limited and mostly depending on precipitation and a small amount from fresh groundwater. According to data obtained from the Royal Netherlands Meteorological Institute, Texel is identified as an area that has low precipitation compared to average level. Besides that, Texel is also recognized as the nation with the lowest groundwater level. For example, the southern part of island is measured with the lowest water level of -2 meter mean sea level, which made the groundwater resource within the area easily be intruded by salt water. Another case study which is in Sri Lanka, where over 400,000 drinking water wells were reported to be either destroyed or contaminated, primarily close to the coastline due to tsunami event. Many of the coastal villages located not more than 10 to 15 meters above sea level, huge area was affected by the inundation. The seawater was immediately filled, the open duct wells and large volumes of salt water were inoculated into the freshwater lands. When the seawater flooded the low-lying areas, there is a high possibility that the saline water infiltrate into the aquifer. Human activities, which lies under the anthropogenic factor, has disrupted the climatic balance and hence triggers the intrusion of saltwater. The decrease in the recharge or and discharge of freshwater often caused by the overexploitation of groundwater and other watercourse constructions. When the rate of groundwater withdrawal has exceeded the natural recharge rate, this is where saltwater intrusion occurs. Other than that, the intensification of hydraulic construction such as dams or watercourse diversion have increases from time to time to meet the societal needs for water. The results of the intake of water from river upstream due to water diversion and watercourse interception by man-made barriers have caused a reduction in the discharge of freshwater to the ocean, hence leading to saltwater intrusion. Land drainage for agriculture or other activities can also lower the freshwater table and hence lead to an increase in salinity, especially in coastal areas.
Groundwater resources affected and extent of damage. What is aquifer? It is a layer to store rainfall from the recharge zone that seep into the soil and enter the aquifer to flow within the groundwater flow area. The aquifer layer can be either confined or unconfined layer. Case study in Terengganu, which is located on the east coast of Peninsular Malaysia, having a coastline bordered by South China Sea and stretching 225 km from Besut to Kemaman. The affected coastline is mostly consists of quaternary rock of marine and continental deposits that comprises of sand, gravel, and sandy clay deposits in littoral and marine environment. Quaternary rock also is categorized to have high porosity and excellent permeability that allow water to be stored in between the grains. There are 13 sampling wells located along the coastline of Terengganu. From the 13 sampling wells, it is found that all the sampling wells containing salinity. The highest sampling well that contains extremely high salinity, 1.89 ppt, is the sampling well B3, followed by B4, KT1, and B1, which is located in a red circle in the figure. Meanwhile, other sampling wells contain from moderate to extremely low of salinity. Next case study in Sri Lanka. On the December of 2004, after a tremendous disaster which is tsunami happened, saltwater intrusions were being recorded in a very large area. A confined Miocene age limestone aquifers exist along northern and northwest coast and throughout the Jaffna Peninsula. Groundwater resources across most of the Sri Lanka coast are dominated by the coastal sand aquifer with estimated total area of 1,800 km squared, tapped by shallow open dark wells and deep wells. Next is case study in China and Netherlands. Due to the increment of the salt concentration in fresh groundwater aquifer, groundwater resources for domestic, economic activities, and agriculture for irrigation are affected. It also caused the plants surrounding the affected area to be damaged due to the unbearable to handle salt stress, consequently decreases biodiversity and eventually turns green lands to infertile lands.
The effect of groundwater contamination. First, drinking water. Saltwater intrusion has decreasing the freshwater supply. Sodium salts are virtually what humans take in from food and drinking water every day. Therefore, there is rarely equal attention on the occurrence of sodium salts in drinking water compared to other toxic pollutants. But excessive sodium content in the drinking water will exert ill influence on human health. Saltwater intrusion has been responsible of the deterioration of groundwater quality and accumulation of metals. Example, mercury or arsenic in well waters, often exceeding the law limits for drinkable. Agriculture. Crops are classified into 4 different categories: sensitive, moderate tolerant, and tolerant. Most fruit and vegetable crops are moderate sensitive or sensitive to salt. Some crops from grass family are proven to be salt tolerant. The plants or crops with low salt tolerance will have huge impact whenever the saline water increases and reaches the upper groundwater zone. Constantly using water with high concentration of salt as irrigation source makes salts accumulated in the soil and eventually damage the productivity of cultivated lands. Next, impacts on wetlands. Soil salinity is lower in the upper zone and the plants are sensitive to saltwater compared to the ones in lower zone. Slight changes in the soil salinity caused by inland movement of seawater can result in water stress of plants and can even cause lethal consequences for them. When experiencing saltwater intrusion, the function of wetlands restoring nutrients has been weakened. Other impacts. Intruding saltwater is slowly changing the landscapes in many coastal areas. High salt concentration kills the plants that cannot handle salt stress, subsequently reduces biodiversity and eventually turns green lands to barren land. When groundwater that supplies lakes, rivers, streams, ponds, and swamps becomes contaminated, this slowly leads to more and more contamination of the surface water as well.
Groundwater remediation method applied from case study. There are 6 remediation works including legislation that have been taken place in treating groundwater. Number 1. Pumping out water from well. This is the process of pumping out water from well until the water quality is good enough to be drank. It is the most common method, cost-effective method used by most residents that have contaminated wells, such as what have been practiced in Sri Lanka and India. Number 2. Chlorine disinfectant. This is the process of treating groundwater with chlorine. It is the most common practice used by all stakeholders. Chlorine are affordable to purchase, and the best way of treating contaminated groundwater is by using combination of dry pellets and dry chlorine granules mixed with water. Number 3. Artificial re-injecting fresh water back to aquifer, or also known as plant recharge. It is a method used in preventing low pressure in groundwater and create equilibrium state between seawater and groundwater. Number 4. Installing barrier. Seawater intrusion can be prevented using solution that reduces the permeability of the soil and thus acting like a barrier. Such case study in Italy that uses gypsum as a barrier created between fracture of carbonated aquifer. It is economically feasible and one of the common practice in a coastal aquifer. Number 5. Desalination, one of the most expensive way of treating groundwater. Contaminated groundwater is extracted and treated in the plant using coastal power generated plant along the process. Number 6. Legislation. Due to overpumping of groundwater had caused seawater intrusion and thus contaminate the groundwater. Law and enforcement action need to be taken into consideration in order to educate people about overpumping of groundwater.
There are 4 outcomes for the remediation action on groundwater by coastal area pollutions. Hi, my name is Vanessa Alexander and this is my project for groundwater, and I will be talking about the outcomes of the remedial action taken or the residual effect. At this point, the well water may become unclear for up to days. To further intensive pumping for drinking water is possible, but would take up to 1 or 2 years depending the rainfall conditions. Repeated chlorination of well should be avoided, as the chlorine residual would contaminate the aquifer and would cause skin rashes to humans when used for bathing. Apart from that, re-injecting fresh water back to aquifer can cause the aquifer or the groundwater wells to be clogged by carbonated precipitations. For barriers, seawater intrusion still can contaminate the groundwater system, as the remediation can only reduce the velocity of seawater intrusion. As for the conclusion, seawater intrusion are becoming possible and increasingly polluted the groundwater flow system.